Welcome to Algebra 1, Unit 5, Lessons 14 and 15, Practice Problems. For each situation, write an expression answering the question. The expression should only use multiplication. Number 1. A person's salary is $2,500 per month. She receives a 10% raise. What is her new salary in dollars per month? So, one thing we need to know is how to convert percentages into decimals. If I say 100%, that equals 1. You're saying you have one whole amount. So if I have 10%, then 10% equals 0.10. That's 1/10 of 1. Now what's important to understand is this is saying they're getting a raise. So when we write the expression, we would say 2,500 times 1, which equals their full original salary, 0.10. By multiplying by 1.10, this gives us the full amount of their original salary plus the 10% raise. Now we can use a calculator, and 2,500 times 1.10 equals 2,750. So her new salary would be $2,750 per month. Number 2. A test had 40 questions. A student answered 85% of the questions correctly. How many questions did the student answer correctly? So now we're not adding a percentage on to an original amount. We're trying to find out how much of an original amount would create 85%. So when we're writing 85% as a decimal, that would be 0.85. So to write this expression, we're going to say 40, which is the number of questions, times 0.85 equals 34. So this student answered 34 questions correct. And number 3, a telephone cost $250. The sales tax is 7.5%. What was the cost of the telephone including sales tax? So if we have 7.5%, this becomes 0.075. And since we want the total cost, we're going to take the original amount, $250. We're going to multiply it by 1.075. because we want the total cost that includes the original $250 plus the extra 7.5%. Now, if we put that in the calculator, 250 times 1.075, the total cost is $268.75. One last thing you can always do is use logic to check your answer and see if it makes sense. If you know somebody is starting out making $2,500 per month and they're getting a raise, then you know that your answer should be more than what you started with. In number two, if we know the test only had 40 questions on it, and this person got 85% of the questions correctly, then we know the number of correct answers must be less than 40. And finally, on number three, we know that if a telephone costs $250, but we had to pay sales tax on it, then we know that our amount should be more than the original $250. So once you get your answers, double check, make sure that the logic makes sense. Is it larger or smaller like it should be? And is it about what you had originally assumed it should be around? Or is it very different than what you would have assumed? If logic throws up some red flags, double check yourself and see if you might have made a mistake somewhere. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. In June, a family used 3,500 gallons of water. In July, they used 15% more. Select all the expressions that represent the number of gallons of water the family used in July. So if we look at A, this is the original amount, 3,500. The 0.15 represents the percent, and they're multiplying that by the original amount, so this correctly gives us the additional amount. So this will take the original amount and add the additional amount to give us the amount used in July. So this is correct. On B, we have the original, but then this just adds 0.15 gallons. And that's not what it should be doing. It should be adding 15%. So B is not correct. On C, we have the original amount, and then we're multiplying by 1 minus 0.15. So this is actually going to give us a reduction of 15%. So this would not be correct. This would actually say we're using 15% less water in July than we did in June. Choice D, we have the original, and then the 1.15 shows the increase of 15%. So D is correct. And E has the original, and then it multiplies it with an increase of 15%. All they did was take the 1.15 from answer D and split it apart into 1 plus 0.15, so it would still represent the same thing. So the correct answers are A, D, and E, all show an increase of 15% more water. If you have any questions about how I solved this practice problem, please use class time now to ask for clarification. Hans' summer job paid him $4,500 last summer. This summer, he will get a 25% pay increase from the company. Write two different expressions that could be used to find his new salary in dollars. So the first method would be the most direct. You take the $4,500 that Han made last summer and you multiply it by 1.25. The 1 would give you the original 4,500, and the 0.25 would give you the additional amount. $4,500 times 1.25 equals $5,625. Another way we could do this is the indirect method. We can take the original amount of $4,500 that Han made last summer, and then we could add the amount that they would make additional, which we could find by taking the 4,500 and multiplying it by 0.25. Now, when we figured this one out, bring down the 4,500. In the calculator, we would say 4,500 times 0.25. That gives us $1,125. Now we add them together and we get $5,625, and we can see that they match. So multiplying by 1.25 is a quicker, more direct method, but finding the increase and then adding that to the original amount will also give you the same answer. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. Page 2. Military veterans receive a 25% discount on movie tickets that normally cost $16. Explain why 16 times 0.75 represents the cost of a ticket using the discount. So number one, multiplying by 1 would give the normal price. Multiply by 0.75 shows a 25% reduction in the normal price. For number two, a new car costs $15,000 and the sales tax is 8%. Explain why 15,000 times 1.08 represents the cost of the car, including tax. Again, multiplying by 1 gives the original cost. Multiplying by 1.08 adds the additional 8% sales tax. So if we are multiplying by less than 1, we are showing a reduction in the amount. That could be a discount, it could be losing population, but multiplying by less than 1 is showing a reduction. Multiplying by more than 1 is showing an increase. So something like sales tax is added on to the original price. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. In 2011, the population of deer in a forest was 650. Number 1. In 2012, the population increases by 15%. Write an expression using only multiplication that represents the deer population in 2012. We know we start with 650 deer, and we would multiply that by 1.15. This gives us the original 650 with the 1 and the additional 15% with the 0.15. And if we put that into a calculator, 650 times 1.15 equals 747.5. But we're talking about deer. You cannot have a half of a deer, so we'll just leave it at 747 deer. In 2013, the population increases again by 15%. Write an expression that represents the deer population in 2013. So again, we could do what we did in number 1, the original 650 times the first year increase of 15%. And now we've had another year and it's increased by another 15%. So again, we will multiply by 1.15 because the 1 gives us the original amount and the 0.15 gives us the 15% increase. We can go back to the calculator and take this amount we came up with by multiplying by 1.15 once, and we're going to multiply by 1.15 a second time. And now we have 859.625. We cannot have partial deer, so we'll round it to say 859 deer. Number 3, if the deer population continues to increase by 15% each year, write an expression that represents the deer population T years after 2011. So since we're multiplying by the same amount every time, this is an exponential function. And exponential functions always look the same way. Starting amount, 650, times the growth factor, 1.15, to the exponent of the input. In this case, that's t for years. So this expression will allow us to calculate the deer population any number of years after 2011 by substituting how many years after in for t. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. Mai and Elena are shopping for back-to-school clothes. They found a skirt that originally cost $30 on a 15% off sale rack. Today, the store is offering an additional 15% off. To find the new price of the skirt in dollars, Mai says they need to calculate 30 times 0.85 times 0.85. Elena says they can just multiply 30 times 0.70. Number 1, how much will the skirt cost using Mai's method? So we'll pull up a calculator, and Mai said 30 times 0.85 times 0.85. And that equals, since this is money, we're going to use the 5 to round the 7 up. And this would be $21.68. Number 2, how much will the skirt cost using Elena's method? Well, Elena says to take the original 30 and multiply it by 0.7. And this gets us $21. Number 3, explain why the expressions used by Mai and Elena give different prices for the skirt. Which method is correct? Mai's method takes 15% off $30, then 15% off the lower new price. Elena's method takes 30% off $30. Mai's method is correct because the additional 15% should come off the discounted price. If you have any question about how I solved this practice problem, please use class time now to ask for further clarification. One $1,000 loan charges 5% interest at the end of each year, while a second loan charges 8% interest at the end of each year. Number 1. Complete the table with the balances for each loan. Assume that no payments are made and that the interest applies to the entire loan balance, including any previous interest charges. So on a calculator, we have the original $1,000 of the loan, and we're going to multiply that by 1.05. This is 5% interest the first year. So after the first year, the loan balance is $1,050. After a second year, we're going to multiply this new balance times 1.05 again. This adds 5% of the new balance to it, and we get $1,102.50. And we're going to multiply this new balance by 1.05. And after 2 years, we'll round this up. The balance is $1,157.63. So the way we were doing this was $1,000 times the growth factor of 1.05 to the power of t, the number of years. Now we'll do it with an 8% interest rate. We have $1,000 times 1.08, and at the end of the first year, you owe $1,080. So we can see that that extra 3% after 1 year costs us an extra $30. After 2 years, we'll take this amount, we'll multiply it by 1.08 again. Now our balance is $1,166.40. So now we can see this extra 3% interest after 2 years has cost us approximately $64. So now we're going to multiply it one more time times 1.08, and we'll round this to $1,259 and 71 cents. So now we can see that extra 3% after 3 years has cost us approximately $102. And the expression we're using for this one is the original $1,000 times the growth factor of 1.08 for the 8% interest to the power of t, the number of years that we're doing it. Number 2, which loan balance grows more quickly? How will this be visible in the graphs of the two loan balances, B and C, as functions of the number of years? So B, we can tell, is growing slower, and C, we can tell, is growing faster. So C grows quicker, and will be steeper on the graph. And number 3, use technology to create graphs representing B and C over time. The graph should show the starting balances of each loan as well as the amount of the loan after 15 years. Write down the graphing window needed to show these points. So the graphing window for X, we know that needs to start at 0. And X needs to be greater than or equal to 0. And we want it to go all the way to 15 years. So we know that X needs to be less than or equal to 15. This will set our window wide enough to see from the initial balance to the balance at 15 years. Now what I did was use Desmos.com calculator. You can see that the 5% interest is the red line and the 8% interest is the blue line. You can see they both start at $1,000. So the Y value window would need to be 1,000 less than or equal to Y, And then we need to see how large the value needs to be. Since C is growing quicker, it is going to be the one that hits the highest total after 15 years. So I'm going to see what the total is. 1,000 times 1.08 to the power of 15. And we could see that the balance would reach 3,172. So a safe window to set that at might be 3,200. That will make it tall enough to fit in all the points. And now you can see at year 15, the 5% interest, the loan costs you $2,078.93. But when it's 8% interest, the loan costs you $3,172.17. So this is the type of difference that an interest rate can cause. This is why it's very important to understand what a credit score is, how it's calculated, and how to maintain your credit score so that you can get lower interest rates, because you can see right here what a big difference it makes between somebody who can get a 5% loan and somebody who has to take out an 8% loan. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. Lynn opened a savings account that pays 5.25% interest annually and deposited $5,000. If she makes no deposits and no withdrawals for 3 years, how much money will be in her account? This is an exponential function, so we start with the initial amount, $5,000. We multiply that by the growth factor, which would be 1.0525. This represents the extra 5.25% interest. And our input is going to be the number of years, which is 3. So the first thing you'll do is the exponent part. We have 1.0525 to the power of 3. And we can see that this equals approximately 1.17. And now we're going to multiply that by the original $5,000. And we get a total of $5,829. And the 7 rounds the 6 up, so that's 57 cents. So depositing $5,000 at 5.25% interest annually for 3 years will give Lynn $5,829.57. If you have any questions about how I solved this practice problem, Please use class time now to ask for further clarification. A person loans his friend $500. They agree to an annual interest rate of 5%. Write an expression for computing the amount owed on the loan in dollars after T years if no payments are made. This is an exponential function, so it always follows the same pattern. We have the original amount, $500, multiplied by the growth factor. If there's 5% interest, you would multiply by 1.05 because you're adding 5% every year. And the exponent is going to be t, the number of years that have passed without paying. This is the expression. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. The real estate tax rate in 2018 in a small rural county increased by 1/4%. In 2017, a family paid $1,200. Which expression represents the real estate tax in dollars that the family will pay in 2018? So choice A says we are multiplying 1,200 by 1/4 and then adding it to the 1,200. So this one is wrong. This represents adding 25%. So this part's wrong. In B, this one is multiplying by 1.25, which is also adding 25%. So that's incorrect. On C, if you move this decimal point 2 places, this actually says we're adding 2.5%. So this one is also wrong. Finally, on D, if you move the decimal point 2 places, this says we're adding 0.25% or 1/4%. So D is the correct expression. If you have any questions about how I answered this practice problem, please use class time now to ask for further clarification. Here are the graphs of two exponential functions, f and g. If f of x equals 100 times 2/3 to the power of x, and g of x equals 100 times b to the power of x, what could be the value of b? So b has the exponent. That means b is the growth factor. and we see that G is decreasing quicker than F. That means the growth factor for G must be smaller than the growth factor for F. So B has to be less than 2/3. We see with A, 1/3 is less than 2/3, so that's correct. For B, 2/3 equals 0.66, and 3/4 equals 0.75. So this is actually greater than 2/3. So it's not B. C, 1 is obviously greater than 2/3. So it can't be C. And D, 3/2 equals 1.5. And 1.5 is bigger than 2/3, which is 0.66. So D cannot be correct. So A must be our correct choice because G is decreasing quicker, so it's multiplying by a smaller number than 2/3. If you have any questions about anything we covered in these practice problems for lessons 14 and 15, please use class time now to ask for further clarification.